Hi everyone! Now that we have written our first program in Go, we are ready to see how Go implements some fundamental programming concepts. We're going to start with variables. Go requires that every variable has a type. And in this installment of Programming for Lovers, we will introduce some of these types with a specific focus on numeric variables. As always, if you enjoy what you see, please like, subscribe, and join our course at programmingforlovers.com. Let's code. The first thing that we need to do is create a folder that's going to contain our code for this session. So if we're going to talk about an introduction to variables and an introduction to types in Go, let's go into our Go src folder. And let's create a new folder in that source code folder that's called anything we like, something like variables. We could call it type. Regardless of what we name our folder, we're going to need a .go file within that folder. So let's call it main.go. And this is going to contain code that we're going to run. So at the very top of our file, what we're going to need is a declaration to Go that we want to run this code. So I'm going to say package main. And that means that we're going to at some point need a func main in our code. So I will have a simple print statement for now. Something like variables and types. And if I were to save that, and I have the Go extension installed for VS Code, I'll get an automatic import FMT statement. So we're ready to run our code, and in fact, this is similar to a Hello World program that we have currently. And within the terminal, I can see that I'm in my Go directory, so I could cd into the source code and cd into variables, and I need to compile with go build, and then I can run my code. So it just prints the statement variables and types. Now we want to declare some variables and start working with them and learn more about the different types that variables can have. I will make one more note before we do that though, which is to talk a little about comments. So comments in any language are going to be notes to ourselves or to someone else that's going to be looking at this code and running the code that can be helpful to them or us because they're indications of what something is doing in terms of the code. So we don't want the comments to be interpreted by the program, by the programming language and converted into some instruction. Instead, we want to have little notes to ourselves. So we can include these notes in one of two ways. So one way that we can do that is via a double slash in Go. So I could say Go won't read this line. And the other way that we could do it is to have a multi-line comment, and multi-line comments begin with /* and end with */. So you see it at this point in time is interpreting func main as part of the comment, and I need to halt that comment, and it will recolor it back to understanding that this is indeed code. So this is a multi-line comment here. These are good for lengthier discussions of explanations of your code, something like that. Okay, so we can start going into main and talking about how we're going to declare variables. I'll declare variables of a few different types. So the variables that I'm going to declare are going to have 6 different types. We're going to have an integer type. We're going to have an unsigned integer type, so that means for everything that's 0 or positive in terms of integers. We're going to have a Boolean variable. Those can be true or false. We're going to have float 64s. Those can store decimals. And we're going to have strings, which will store essentially words or series of words, lengthy or short text. And we're also going to be able to store a single symbol. And the type that we're going to use for that is called byte. For now, every time that we represent a variable, Go is very strict about the type that the variable has. Some languages are more flexible and variables can kind of take different values at different points in time. But Go wants us to declare a variable, think of it as a container that's going to hold some value later, and it wants us to have the type for that variable. So if I want to declare a variable, and let's say that variable is called j, and I want it to have the integer type, so j is going to be an integer, I'll use the var keyword, var, you see it colored blue there because it's a keyword. J is the name of the variable, and then the type of the variable there is int. Let's declare a few more. So let's declare a variable named x called, and that's going to be a float64 type. Let's declare a variable called yo and make it be a string. And these variable names can be anything you like as long as you're not using a keyword. So you can't name a variable var, you can't name a variable int, something like that. Let's declare a variable u that's going to be an unsigned integer. How about a variable named symbol that's going to be hold a symbol for us, and that's going to be of type byte. And we're also going to have a variable called statement that's a Boolean value, and this is going to be true or false. So let's save our main.go. I'm going to save that. And we can come down here into the terminal, and I could try to compile my code. Make sure to save before we do this. And what you'll see is that Go does not like the fact that we have declared variables without using them. So it's giving us feedback here and saying on line 15, character 6, line 16, line 17, line 18, line 19, and line 20, on all those lines there are problems. So we can see those lines in our code, and we can see that all these variables have been declared and not used. So Go wants us to use any variable that we declare. This is kind of a check to make sure that you're not declaring variables that you don't wind up using and cluttering your code with all these variables that you thought you were using but you actually weren't, or that you declared but then you decided not to use. It's just good coding practice that if you want to declare a variable, you probably should use it in some way. So the way that I am going to use these variables is simply to print them, because what we might wonder is what are the values that these variables have. I've declared them, but I haven't set them equal to anything. I haven't assigned a value to any of these variables. So let's see what values these variables have. Okay, so we could print, for example, each of these variables. We're going to print j, we're going to print x, and we're going to print each of these on a separate line. Let's print yo, let's print u, let's print symbol, and then of course statement. So that should resolve these compiler errors that we saw. If I save this, and then I can actually hit the up arrow, and that will give me my most recent command. If I hit it twice, it would give me 2 commands ago. I'm going to go build again. I'm going to see that I don't have any compiler errors, and so if I hit up enough to see the point at which I have /variables, and if you're working with the Windows machine, you would just type variables.exe at this point. This will run our code, and it will show us the default values that each of these variables has received. So the default value for the integers, you're going to see a lot of integers getting printed. The default is 0. The default for a float64 is also 0. You might like to write it as 0.0, something like that. The default value for a string is something called the empty string. It is a string, but it has no length. So we think of it as just a word of no length. It's kind of like a 0 string, if you want to think about it that way. We also have a uint. It defaults to 0. And that's the fourth thing that we see printed. So the empty string, there was nothing printed down at the bottom. Strangely enough, the symbol default also appears to be 0. And then finally, the default for a Boolean variable is always false. So every time we declare a Boolean variable, the default value is always going to be false. Now, maybe we could incorporate a few other things that might cause the compiler to get frustrated with us. And because, especially if you haven't worked in a compiled language before, the compiler is really nice. I think of it as like a grammar checker for us. it also can be strict. And so one of the things that we need to get comfortable with is learning how to interpret the output of the compiler. So for example, we might go up and say, I forgot my import statement. And even if I save that, because I've got a Go package installed, every time I save, it's going to automatically import FMT for us. So this is the benefit of programming with nice text editors and everything imported for us, but we would get one type of compiler error if we forget an import statement. Another thing that we might do is accidentally not having the right variable name. And so I've talked a little about this, but let's go to the terminal and compile after I save. And again, I've mentioned this a little bit, but every time that you have a compiler error with Go, it will tell you the line and then the symbol where that error happens. So here it says you declared this and it wasn't used, and also I have no idea what high is. So high is undefined at that point on line 25. So start getting comfortable with this, because there will be compiler errors. Even if you've programmed before, if you're learning a new language, everyone has compiler errors. No one programs perfectly without any kind of compiler mistakes. My suggestion to you is to compile frequently, so that way if you're making mistakes, you're not making those mistakes permanent. All right, so for now I'm going to fix this back to Yo. And one other compiler error I might profile is if I forgot that terminal bracket. And this can be an annoying one. Yeah, I have an unexpected end of file on line 30. So it's saying Go is surprised that I got to the end of the file. I was expecting there to be a bracket here. So that's another, it may appear cryptic the first time you see it, but all we need to do is give it a closing bracket. All right. So we have not really done anything yet. And so instead, let's take each of our variables and assign each of our variables to some value. So there's a few ways of doing this. One way would be to instead, so we could update j equal to its value, and we could update x to be equal to -2.3, and we could set variables in this way. Another way you might want to do it is to say, well, I don't want to declare my variables and then give them values. Instead, let's do that process when I declare. So we're going to have var jint is equal to 14. And so this will declare j and immediately set it equal to be 14. We're going to have var x float 64, and we're going to set it equal to -2.3. We're going to set yo equal to, let's make it be the string high. And let's set uint also equal to 14. And let's set our symbol equal to h. So a string is always enclosed in double quotation marks, and a symbol is going to be enclosed in single quotation marks. And if I didn't want that statement variable to be false, let's make it true. Okay, so now when I compile and I run my code again after I save, I'll see those updated values. So I see that 14 is the value of j, -2.3 is the value of x. We see that yo gets printed high. The value of u is 14 also. The value of symbol is strangely 72. So behind the scenes, even though this is we're thinking about it as a symbol, Go is going to be thinking about these as integers. There's a table behind the scenes where each symbol corresponds to some integer. And so that mapping of sorts is what Go is thinking about. And so it's viewing each symbol as an integer. We can say more about that later when we talk about strings and symbols and discuss this in a later point in the course. Finally, you see that the statement variable's value of true was printed. Now, this is a lengthy way of defining variables. So one way that I could instead declare these variables would be via what we call shorthand declarations. So the shorthand declarations are going to help us avoid lengthy var j int statements. If I know that I have a variable and that variable is called I, and I want to set it equal to -6, I can use colon equal to -6. So this is equivalent to var I int equal to -6. And I's type int is inferred automatically by Go. I could have another string called hi. Let's make things confusing. By setting its value equal to yo, this will have type string by default. We could have another variable called k, declared equal to 34. And here's where you might wonder, is this going to be an integer or is it going to be an unsigned integer? And many languages, for technical reasons, or a few I should say, don't actually even include an unsigned integer type. They want everything to be an integer. And for that reason, if you just declare a positive integer, it will automatically have type int. So it will, k could be updated later to have a negative value. We're not going to require k to be positive just because it starts off as positive. If I set y equal to 3.7, this has type float, 64. And a second statement is equal to true, has type bool. So this, in practice, is the type of thing that when you're declaring variables that have simple types like strings and integers and float 64s, you're going to use these colon equal declarations more often than you're going to use these original declarations. But knowing how variables get declared in this way in Go is actually pretty important and will be useful much later in the course when we work with more sophisticated objects and larger variables. So the purpose of having number types in Go is to be able to work with them in terms of as data, which means at the end of the day doing arithmetic on these things, taking two variables and multiplying them together, for example. And so let's perform some arithmetic on the variables that we have declared. One thing that I might say before I do that is I'd like to compile and run my code, and let me, in order to have code that will compile, I'm going to print out everything that I just declared. So I need to print out I, hi, k, y, that's a lot of rhyming things, in second statement. And this is a shortcut print line statement where everything is going to be separated by a space. So if you want to print multiple things, you don't want them to all get printed on their own line. You can simply add a comma after every new thing that you're printing. So I will compile this code and run, and we'll see all those variable values get printed on the final line with spaces separating them. We'd like to do arithmetic though, as I mentioned. And Go is going to, like most programming languages, follow like a standard order of operations when it performs arithmetic. So if I wanted to, for example, take the expression I plus 5, multiply that resulting expression by 2, and then multiply that by whatever the value of k is, and then print that to the console, then we could do that. So I could take 2 times, and I'm going to put I plus 5 in parentheses because I want to add 5 to I first, and then multiply the result by 2. And then after I do that, I want to multiply the result by k. So this is going to go in and it's going to say, what's the current value of I? Add 5 to that, multiply the result by 2, and what's the current value of k? Multiply whatever I just had by that. Right? If I wanted instead, I could have 2 times y, remember y is a decimal, and maybe I subtract 3.16 from the result. So both these types of expressions are going to be fine and acceptable to Go, and this is how we're going to start doing more sophisticated things in terms of using these numeric variables that I am declaring. So I can go into the terminal and see what gets printed. Now I'm not very good at arithmetic, so I hopefully won't have to go in and figure out what 2 times the quantity I plus 5 times k is. But we're going to let the program tell us, and this is a classic example of me not saving the code. So let's save this first. Go gave us a prettier way of representing that. And now let's compile and run. And we see that 2 times I plus 5 times k is negative 68. And 2 times y minus 3.16 is 4.24. And we can trust Go to be our calculator. One other thing I might point out is that hopefully you'll see that one of the things I'm not doing is having everything run into itself line after line. So there is this becomes very difficult to read if I do this. And whereas in practice, everything that I've done is in sort of its own little area. And Go is not going to care how much white space you put between your lines. So I could put more than this. I could put 3 lines of white space in here and as much white space as I like. And I would say that this looks probably a little bit silly, but from years of teaching people how to program, when I look at student code, people usually err on the side of not having a bunch of white space. Not having enough white space, I should say. It's rare that I see somebody and I say, you know what, you could delete some of the lines in your code and kind of compress things down. Usually you want to have more white space than you're currently using. But if I were to have that much white space, Go will get frustrated with me. But if I could have saved that and run it, it's still going to be fine. So you can have as much white space as you like, and you can still have code that's going to compile. In this case, the Go extension has compressed things down into a normal amount of white space for us. But make sure that you have some gaps in your code. Go is absolutely fine with single lines of white space here. Or I should say the Go extension is fine with that. Let's see what happens, though, if I were to do something like that. You know, if we were in a math class, this type of expression seems completely reasonable. We're used to seeing, you know, if you see parentheses and a number next to it, well, you can infer that that means multiplication. If I were to compile this, though, Go doesn't know how to interpret this. So a common error that I'll often see with introductory programmers is making sure that you realize that the language behind the scenes is not an intelligent thing. It's not currently able to infer that this is what you mean, and you need to make sure that you remember to put in your multiplications, things like that. The other thing that I might do is, and this is something to know about variable types, is to think that, well, let's do k times y. So k was 34, y's current value is 3.7. Say we wanted to multiply those two things together. I could save, and then when I compile this, I'm going to get an invalid operation on line 42. It's going to tell me that I have mismatched types int and float64. And this goes back to the point about the strictness that Go has. Go really doesn't like it if you try to do arithmetic on things that have different types. It wants to make sure that you really understand what types that you're working with. And in this case, if you're multiplying k and y together, you presumably want a float 64. You presumably want that to be a decimal, that whatever that resulting value is going to be. And other languages might allow you to multiply an integer by a float and infer that a float 64 is what you want to obtain. Go wants to make sure that you appreciate that k is an integer. And so what we can do is cast k to a floating point decimal. So k is still an integer, but we cast its value. I'm going to turn on my word wrap. We cast its value to be a float 64 for the purposes of the multiplication. And so now everything should be okay. If I compile and run, I'll see this printed. Now, this is a good teachable moment. I was hoping something like this might happen. If you were to write this out by hand and say, what is the product of 34 and 3.7? Well, you would presumably get not 125.800000001, but 125.8. That's the true value of this multiplication. And you might look at this and say, well, that's weird. Why has it made something that's approximately equal to 125.8, but that then has all these zeros and then a 1. You might have seen a 7 followed by a bunch of 9s. This is because each variable can only be assigned a finite amount of space, and so the collection of possible values that you can represent in a computer are not infinite for that reason, and so you wind up with very small round-off errors that you incur in any programming language, but that don't really affect anything too badly usually because this is so far past the decimal point. We're going to discuss what exactly this means to store a variable in the memory much later in the course. But for now, understand that this is something that you see anytime that you're working with decimals in any language. The next thing that we might do would be let's look at something like division. So let's print the result of, say, k, which is 34 divided by 14. Now 14 goes into 34 2 times, not quite 3 times, and it's going to have some remainder. And I believe that that's going to be like 2.428 something. However, if I were to compile this and run it, we might expect 2.4285, something like that. But what we instead see, 2. And this is not that the programming language has made a mistake, that it's bad at arithmetic like me. Rather, it's that when you have 2 integers and you divide them, dividing 2 integers corresponds to what's called integer division. And a short way of describing integer division would be to say we throw away the remainder. So if I have 2 integers and I want to divide them, well, the result in Go is always going to be an integer, so we get rid of what the remainder is. If I wanted this division to happen and get the correct value, then I would instead need to cast k to be a float 64. K is still going to have that integer type. And now I'm going to divide by 14.0. So I'm going to make sure I indicate that that's a decimal that I'm dividing by. And let's see what happens. There we get 2.42857, 1 repeating. Not every type conversion is going to work. So things like Boolean of 0 might be false in another language, but Go doesn't allow it. Okay. But for the most part, when we're doing type conversions, you're probably thinking about converting, say, an integer to a float, these sorts of things. Or maybe a symbol to a string, but we'll talk about that later. Finally, I want to make one more point here. We've seen all the basics of how to declare variables, the different types that basic variables can have, and a little bit on working with arithmetic. Let me imagine that I declare a variable p. And let's say that that variable p has type integer, and I set it equal to negative 187. Negative 187. And let's say I want to declare a different variable s, and it's an unsigned integer, and maybe I cast p. So p is still going to be an integer, but I take the value that's currently in p, and I create that value as an unsigned integer, and that variable s is going to get its value. You might stop for a moment and think about what even might occur here. One thing that you might imagine would happen, that I might imagine would happen, would be, well, if it's negative 187 and you want to convert that to an unsigned integer, maybe that gets converted to 187. That's a very natural thing to think. And so let's see what happens when I save, compile, and I, of course, need a print statement. That would be nice. I need to use my variable. Let's see what value it has. You might have imagined it was going to be 187, but instead what was printed was 1-844-6744-0737-0955-1429, and that is definitely not 187. Let's do one more example of this. So let's set m equal to this in no way specifically chosen number, 922-33720-368-544-775-807. And now let's print m plus 1, whatever the value of m plus 1 is, one more than m. Now, I feel like this is not too hard, right? We should be able to know what's going to be printed here. It's a long number, but I'm probably going to just see this 7 get replaced with an 8. Again, I'm not good at arithmetic because I have a PhD in mathematics, and that makes you terrible at arithmetic, but presumably I know I just need to replace that 7 with an 8. So let's go into the terminal. Let's compile. And what do I get? Line 56? I don't even get this to run. So Go says, I refuse to add 1 to this. We're back. I figured out what my bug was. My bug was that I incorrectly typed in the value of m. So m has a very special value, but it doesn't have a special value if I type it wrong. And so instead of, when transcribing it, I needed to get rid of one of those 4s. I had 1 4 too many. So if I save this and compile it this time, I should see a compiler go through. That's good. And now, if I were to run this, I would hopefully see that number with 1 added. So I should see it end in an 8. And I do see it end in an 8. In fact, it's the number that we were hoping for, but it's negative. And so this is curious. You might wonder what in the world is even going on. It's an example of something called integer overflow. So we declared m to have type int, and we set its value to this large number. But there's only a finite amount of space that can be used to store possible values of integers. So that means that there's going to be a smallest, most negative possible integer, and there's going to be a largest possible integer. And so we happen to set m to be the largest possible integer. And when we add 1 to it, what Go says is, I'm out of space, so the only thing that I can do is make it the smallest possible integer, which is negative that long number that you see. And this is a special number. It turns out that these things are related to powers of 2, and we'll talk later in the course about exactly what this value is. I'll see if you can figure out what makes this value special. But if we add 2 to it, then you'll see, well, it's that thing that we just had, that negative number, plus 1. So arithmetic is still working, but it's working in this circular fashion. And that's how all programming languages are going to work, because you can only store an integer in so much space. There's only a certain range of values that an integer can have, and if you want a larger range, then you need to start declaring your own types and that sort of thing. Although for the purposes of this class, you're going to be fine with the range that we have typically. The same sort of thing is happening when we declared p to be an integer and set it equal to negative 187. When Go tried to convert that to an unsigned integer, what it said was, well, you told me negative 187, so I'm assuming that I'm starting at 0, the smallest unsigned integer, and then I can't go down because then I'd go into the negative integers. So what you must mean is that I want to start at the maximum possible unsigned integer and come 187 elements down. That, again, is an example of overflow or underflow, these sorts of things, and the fact that we only have a finite amount of storage. And this is related to what we saw before with floating point decimals, where sometimes you'll do a multiplication or something and you're expecting it to be 125.8, but instead it's 0.800000001, and that's because you only have a finite amount of storage for each floating point decimal too. This is something to keep in mind. It will come up later in the course. It's something that is an important topic to know about programming in general. It's not specific to Go, but we'll say more about that later. In the meantime, I hope you had fun learning about variables and types. I'll see you next time, and happy coding.